Hi all, today we are going to learn about radius ratio rule. Simply call it as triple R. For captions, please click this button, like, share and subscribe to my videos. This radius ratio rule deals with ionic solids. And what is ionic solids? That means there is an electrostatic force of attraction between cations and anions. Cations are smaller in size because they lose electrons, while anions are larger in size because they gain electrons. Okay. Now this radius ratio rule is a part of a solid state chapter. In solid state, we consider the constituent particles, and these constituent particles are nothing but atoms, ions or molecules. We assume the constituent particles are spheres. Okay. Now, these ions play a very important role in the formation of the ionic solids. The arrangement of the cations, that is smaller spheres, with respect to the anions, that is larger spheres, is called radius ratio rule. So, this is what we are going to learn, how the arrangement of the spheres are taking place. So, radius ratio rule is all about radius of cation by radius of anion, small r plus by capital R minus. Remember, this is not the formula. It's not a formula. This is the ratio of cation to anion. Please remember this. You can see these are the anions, the negative charge anions, which are larger in size, and this is the cation, which is smaller in size. Okay, this ratio depends completely on the cation to anion. Look here, if there's exact size of the cation, that is perfect fit. If the size of the cation is smaller, you can find the overlapping of the anions. If the cation size is larger, then you can see a huge amount of distance is between the anions. This radius ratio rule is exactly to tell what should be the size of the cation with respect to the anion. The ionic bonding completely depends upon electrostatic force of attraction between anions and cations. Let's discuss the radius ratio rule for coordination number 3. When I say coordination number 3, it means with respect to the cation is touching 1, 2 and 3 anions. So 1, 2 and 3. The purple spheres are anions and the green sphere over here is cation. Okay, this is how they are arranged. Now, with respect to one anion and one cation, we are going to discuss the radius ratio rule. Now, okay, what do you observe over here? This one is the radius of the cation, which is denoted by small r, while this one is the radius of the anion, which is denoted by capital R. Okay, both combined together, we can denote them as R plus R. So the small r is the radius of the cation, whereas the capital R is the radius of the anion. Okay, now for this angle 30 degrees, okay, this one is hypotenuse and this one is adjacent, and as you can see, it is a complete right angle triangle, adjacent and hypotenuse. So when you have adjacent and hypotenuse given, we can use the formula cos. Okay, now cos theta is equal to adjacent by hypotenuse. Okay, now what is theta given? Cos 30. So cos 30 is equal to adjacent by hypotenuse. Now what is adjacent given over here? R, capital R by capital R plus small r. Okay. What is cos 30? Cos 30 is equal to root 3 by 2. Okay. Now, so root 3 by 2 is equal to capital R by capital R plus small r. So root 3 capital R plus small r is equal to 2r. So root 3 r plus capital R plus root 3 small r is equal to 2r. Okay. Now root 3 small r is equal to 2r minus root 3r. Okay. Now, so root 3r is equal to r common 2 minus root 3. So now, okay, 2 minus root 3. R by R is equal to 2 minus root 3 by root 3. So R by R is equal to, substituting the values, we get the answer as 0.155. This is radius of cation to anion. This is the radius of cation to anion. Some people might ask, what if we take cos 60? So cos 60 is equal to 2 by root 3. So r by r plus r is equal to 2 by root 3, and the value is minus 0.155, which means this is not existing. When you have negative value, that means there is no void present and there is no space for the cation to fit into this. Minus value minus 0.155 means all the anions are very closely packed. So hence we are not going for the value cos 60, that is this one. We are going to discuss about coordination number 4. It means one cation is surrounded by 1, 2, 3, 4 anions. 1, 2, 3, 4 anions. Okay. Now we are going to discuss about it. Okay. In this, we are going to specifically select A, C, D. A, C, D as a triangle. A, C, D as a triangle. In this A, C, D, we have a face diagonal, okay, and a body diagonal or a cube diagonal. AC is the face diagonal and AD is the body diagonal or the cube diagonal. Now let's discuss it. We have a face diagonal FD is equal to AC, that's equal to root 2A. Okay. Now face diagonal AC is equal to root 2A. The relationship between radius and the edge length of a face diagonal A is equal to root 2R. Okay, let's keep it aside. Now we'll discuss a body diagonal that is equal to AD, that is equal to root 3A. Now for this derivations, I want you all to watch the previous videos. In the previous videos, you will understand how did I get root 2a and how did I get this one and how did I get this one. Okay. Now, AD, now we have AD is equal to R plus R plus R plus R. That is 2R plus 2R, small r's. Now, root 3a is equal to 2R plus 2R. Okay. Now, substituting the value of a, now root 3, a is equal to what? Root 2 capital R is equal to 2 capital R plus 2 small r. Now, dividing by 2 capital R on both the sides, we get root 3 into root 2 capital R by 2R is equal to 2 capital R plus 2 small r by 2R. Okay. Now, solving this, we get root 3 by root 2 is equal to 2 small r by 2 capital R plus 1. That will give us root 3 by root 2 minus 1 is equal to 2 small r by 2 capital R. 2 get cancelled. Solving this, we get the answer, that is 0.225. 0.225. So this 0.225 is the radius of the cation to the anion ratio. Radius of the cation to the anion ratio. Now we are going to discuss about coordination number 6, that is octahedral void. In this we have the triangle A, B, C, which is a right angle triangle. So as per Pythagoras theorem, we have AC square is equal to AB square plus BC square. AC square is equal to AB square plus BC square. Okay. Now let's discuss about it. Okay. Now we have triangle ABC. According to the Pythagoras theorem, we have AC square is equal to AB square plus BC square. Okay. Now AC square, you can see here capital R. AC square, you can see here capital R, 2 small r's, 1 capital R. That is equal to 2 capital R plus 2 small r. That is equal to, and AB square, you can see over here, AB is equal to capital R plus capital R, and BC is also capital R plus capital R. So that is equal to 2R whole square plus 2R whole square. Okay. So 2R plus 2R is equal to 8R square. Okay. Right. Sorry, this one is whole square. Now 2R plus 2R is equal to 8R whole square and square root of square, that equal to 2R plus 2R is equal to 2 root 2R. Now substituting it, so 2R minus 2 root 2R is equal to 2 smaller. So 2R, now taking R common, 2 minus 2 root 2 is equal to 2 smaller. So R by R ratio is equal to, so 2 minus 2 root 2 is equal to by 2 is equal to R by R. Substituting the value, we get the answer, that is 0.414. This is the radius of cation to the anion. Okay, let's discuss about coordination number 8. You can see one cation which is touching 8 other anions, and it's a body centered, or you can call it as cube diagonal. You can find a cube diagonal which is A and D. AD is the cube diagonal and its coordination number is 8. Okay. Now let's see. So we have AD is equal to root 3A. You can look at my previous video for the derivation. 2R plus 2 capital R. Okay. Now root 3 into 2R is equal to 2R plus 2 capital R. Now root 3 is equal to 2R plus 2R by 2 capital R. Calculating it, we get 2R by 2R plus 1. This value will come over here, this will go over here, so 2 will get cancelled. Now R by R is equal, so R by R, small r, radius of the cation by radius of the anion, is equal to 1.732 minus 1, that is equal to 0.732. So the radius of cation to anion ratio is 0.732. Let's discuss the summary, the radius ratio rule, the summary of it. If it is less than 0.155, that is the radius of the cation to anion ratio, then the coordination number is 2 and the void is linear. There is no example for it. So if it's in the range of 0.155 to 0.225, then we have coordination number 3 and triangular planar, and example is B2O3. If it's in the range of 0.225 and 0.414, then we have coordination number 4, tetrahedral, and SiO2, zinc sulfide. 0.414 to 0.7326, octahedral, NaCl, magnesium oxide. 0.732 to 1, coordination number 8, cubic and cesium chloride. The highest is 1, coordination number 12. It's occurred in close packing, that is CCP and HCP, and mostly observed in metals.